Hi, my name is Franklin, and today I'm going to talk about translating Chinese into Morse code. You're probably familiar with Morse code. It was the way of sending messages on telegraphs in the 1800s. The original encoding scheme really only contemplated characters from the Latin alphabet, so letters A through Z, as well as numerals 0 through 9. And it sent each of these as a series of electrical impulses that we represent here as dots and dashes. And as the telegraph network spread across the world, it was relatively straightforward to add new encodings for different alphabetic languages. And so you might have letters with diacritics that would be slightly different. But in 1871, when Hong Kong and Shanghai were connected to the International Telegraph Network, they had a problem. That being that Chinese is a character-based language and with thousands and thousands of unique characters, and so the same strategy doesn't really work. A telegraph operator working in English can memorize what A through Z are and can transcribe messages as they come off the wire. And that would be unfathomable to do for something like Chinese. So what ended up happening is that these first telegraph lines were built by European companies, being the Great Northern Telegraph Company of Denmark and the Eastern Extension A&C Telegraph Company of the UK. And since they were European companies in the 1800s, they naturally chose some Europeans to come up with the code. There were a couple of different iterations. The one that we're seeing here on the right is the Chinese Telegraph Code of 1871, which was put together by a French customs officer based in Shanghai named Viguier. And the general approach was that they took the most commonly used characters, and so starting with about 5,400 of them, although this grew up to about 6,800, and they mapped each of them to a 4-digit code, so 0000 through 9999. And if we look at a concrete example, if we take the character dong, which means winter, if you look that up in a code book, you'll see that it has the value of 0392, which then you can use the normal international Morse code representation to turn into dots and dashes. And I built an app. I have this link here. I'll have it at the end as well. That basically steps through this, and so you can put in a bunch of Chinese characters, and it'll give you the corresponding Morse code. This has some implications. You might notice that with 4 digits, we can actually represent 10,000 things, and so we have quite a bit of extra room. These code books were arranged in a way for searchability, and so given a character, you could, based on its characteristics, find the right place in the book, and then look up what the digits were. When they arranged the book, they ended up leaving a bunch of extra spaces, which you can see here on the right, just in case in the future they needed sort of to add new characters that came into vogue without having to kind of reshuffle everything. The second implication is that this is actually fairly slow and verbose. So if we go back to the International Morse code, you'll see that this is actually arranged mostly for English letter frequencies. And so E's are very common and therefore very short, whereas Y's and Z's are quite a bit longer. And digits themselves are pretty long. If you're trying to send a single Chinese character that is represented by 4 zeros, then you're on the hook for 20 long dashes. And telegraph messages were also priced by length, and so you would be paying for all of that. So in addition, there was this kind of weird situation with plain text and secret messages. So in English, telegraph operators had developed a set of kind of special words that were not commonly used to represent longer phrases that they might come across. So if you got a message that said toothbrush, what this actually meant was that your telegram had been delayed in transmission. And this was great because it was less expensive, it was faster, but the telegraph companies were not a huge fan because this cut into their profits. So they developed a set of regulations where plain text messages were priced differently from secret ones where the sort of meaning wasn't immediately obvious. And these prices were much higher per word. So as an English speaker, you had a choice between, do I want to send this message as plain text or in secret? And while this originally had nothing to do with Chinese, it was kind of caught in the crossfire. Because Chinese was intermediated by these digits, it had no choice but to be priced, but to be lumped in with all of the secret messages, which meant that it was even more expensive. This problem ended up going away eventually. In 1893, the government of the Chinese Republic and the Qing dynasty negotiated a regulatory exemption and made it so that if you were sending a message with Chinese characters in a code book, then it would be priced as plain text rather than as secret, which is an improvement. So here we have the telegraph the telegraph code of 1871. It works, but definitely has some drawbacks. There were a bunch of different ways that people tried to improve on this, and I'm going to dive into one which is referred to as trigraphs. So a trigraph is basically just a fancy word for 3 alphabet letters. As we noticed before, digits are pretty long in Morse code, but letters are much shorter. And so if we were able to map each Chinese character to a sequence of letters, then that would be a lot faster. And we can actually do better because we don't need nearly as many letters. We actually only need 3, which gives us more than enough space to kind of represent all the letters that we want. And so this is great. Going back to our example of winter, the trigraph of APB is much shorter in Morse code. And this isn't just a fluke. If we jump back to the website, we'll see that this poem originally in Morse code, in digits, when we switch over to trigraphs, is like half the length. And this is true for a bunch of different things. So that seems great. There was a catch, though. So when this was developed originally, Latin characters were not very widely understood in China. And so the codebooks had a mapping of Latin characters to Chinese ones that were phonetically similar. So instead of A, B, C, you had I, B, and Xi. And that was great because it meant that the operators could work entirely in Chinese. They could look up these characters like they were on the right. Each of those boxes has the trigraph kind of in the top left, and then the digit representation in the bottom left, and then the character itself on the right. Eventually, this mapping between Latin and Chinese characters became less necessary as kind of exposure to Latin letters was more widespread, and so eventually disappeared out of codebooks. And cool. So to give a very concrete example of, we have a phrase, I like eating baos, which we have the conceptual equivalent in Chinese, and we can see that, the digit representation in Morse code is fairly long, and with trigraphs, it's actually probably just about the same length as the English phrase, which is pretty cool. So we've talked about 2 ways that Chinese was encoded to Morse code. Both of these had an intermediate step where they were translated first to digits or to trigraphs. And this extra step is still common. So 100 years later, if you find yourself trying to type Chinese on a computer or into your phone, it's actually not that different. You might be using some type of romanization, and rather than a person searching in a book for the right output, it's your computer, but we're still kind of a step removed. And Chinese is weird and different when you compare it to English or other alphabetic languages. And so that's all I have. Thank you so much. I encourage you to check out the app and play around with it. For non-Chinese speakers, I have a bunch of preloaded phrases and poems that you can kind of click around with and get a sense for how this all worked. I highly recommend this book, The Chinese Typewriter, which goes into a lot more detail about both Morse code stuff, but also just all the different ways that people tried to create a typewriter for Chinese, which has a lot of the same types of problems. And yeah, that's about it. Thanks.